Hey everybody, this thing is ready to fill with oil. It's all sealed up. We're going to check all the hydraulics out after we fill it. First time shot, you'll get to hear it and see it, and then we'll go through how this thing works. Sound good? Alright, when you're filling with oil, we're getting down to the end here, but this would not be the way to do it, pouring it this way out of the bucket. To properly control a 5-gallon bucket, even when it's brand new, when you open it up, there should be enough headspace that none of the product will come out when you just set this cap on the very top. And the way to regulate the flow is by twisting the container. Now it requires a little setup to get this all talking just right. Let's see, is that better? But there we go. Now we're filling. And just by rotating this, you can turn it on or off. I don't know if you can see that. So this is all weight 32 grade hydraulic oil from O'Reilly. And we shopped around, we found a variety of prices. Now this liquids are heavy, so anything that has to be shipped has that additional fee on it, which is kind of expensive. So even if you're buying stuff for your machine shop, all the auto parts stores have this type of fluid. It's super common there. So our most local auto parts store, O'Reilly, has this hydraulic oil available. It may not have every dream extra additive in it that I may want, but I'm probably going to run this for a while and flush it in this machine. So it's definitely a commodity that I wanted to buy as cheaply as possible for this fill. Also, the grade, that 32 grade viscosity, we sent a sample off to Blackstone Labs and they sent it back, and it told us that what was in the machine was 32 grade ISO, and so we're replacing it like in kind. Here's our Blackstone Laboratories oil report from our Tsugami. This is exactly what we sent off and got back from Blackstone. So they address that they didn't find any contamination due to the coloration that we noticed. But it did talk about some copper and iron being a little bit too high, and that otherwise it doesn't look too bad. So again, key things are we have kind of high elevated copper, maybe a little elevated iron. Zinc was high, indicating some of the oil properties were still good. Phosphorus as well. And here's our Saybolt unit seconds and our centistokes. And this leads us right into a ISO 32 hydraulic oil. So we told them what we were looking for, and they reported exactly the answer we wanted right here. It's in the ISO 32 range, and additives are typical of hydraulic oil. So we got the answer we wanted. We also learned a little bit about our machine. It's pretty clean. I was especially glad to see that it didn't have any water or antifreeze in it. And it did have a teeny bit of solids though. So we'll clean it, flush it, and run it again. Again, in this casting is just a big hydraulic pump, and it actuates this table, makes it move back and forth. It's a neat feature of the machine. It's semi-automated in that way. It will move back and forth in this direction. This whole table, we'll see it here in a minute. And on the feed wheel, you'll see it bringing the grinding wheel closer to the work. So it's you can set it and let it run for a little while, or you can run it manually. I'll point it out if you can't see it. Is right here. It's a little bit below the high mark there, so we don't have a lot more to fill it, and that's actually plenty right there. So let's call that good, and we'll start the machine up next to see how this works. Okay, let's look at our electric cabinet. Now, first of all, you want to lock out, tag out. So we have the machine unplugged. There's no incoming power, and we have different wire colors also. Here's the low voltage, white and purple. And we have the very bright colors for the three-phase circuits. The buttons go in this original cabinet, the on-off switches and it's a real clean setup the way they had it originally. So we thought we'd just reuse the cabinet to the best we could. Now the fuses over there on the right are the incoming power, and the on the left we have our contactors and circuit protection for each individual motor. There's 3 of them. And to design it all, we used Uglies and our local electrician to help us. They'll always feel it's a great idea to be as knowledgeable as you can when you're working with your electrician. So Uglies is just a super resource for that. So it helped us with the motor information from each motor, and we use that to define full load amps and also the wire sizes. So keeping all the phases correctly organized allows you to, it enables you to make sure all the motors are going to turn the right direction the first time, which worked for us, which was great. So we'll close up this main cabinet because that's just how it works right there. And the other reason we chose the 24 volt was to keep low voltage DC out to the switches and keep the rest of the high voltage stuff back in the machine. So there's a little more work here to do to neaten up these wires, but it's plenty good enough for the test that we're going to do today. And you can see where some of these compartments have been harvested to get reused. So good enough for our test, so let's move on to that next. All right, so we want to test all 3 of these. We just got this buttoned up. We're all full of fluid now. I'm going to turn the grinding wheel on, and I'm turning it right back off. We don't need it to test the hydraulics, but that's running in the right direction, I can tell. And that lit up the coolant pump. So really it's all about this pressure oil pump and how the table actuates. So let's see if we can get this turned on and see what it sounds like with a fresh batch of fluid. Ready? Actually sounds pretty good. So this is the main lever that switches it from manual, driven off the wheel, to automatic, driven on hydraulics. So we've got our stop set for about the length of the maximum piece size. And I believe this drives the speed, so let's turn it all the way down. And we'll turn it into automatic, and we'll slowly, there it goes. That's getting some air out of the system somewhere. Come on. There it is. That's pretty cool. All right, let's turn on the DC work holding motor. Now it's a shunt motor, so it's going to pause for a second, and then it should start up. So there it is. And that's been lubricated as well. That's cool. Okay, this is set. This dial has 4 readings, 4 different positions, and they are no feed, feed left and right, feed left, or feed right. So I took it off. I made sure I put it on feed right. So every time it comes to the end, this advances. There it is. Now you can adjust this to tell it how much to feed, and you can get it to feed. The smallest increment is 1/10, 0.0001. So it's a very fine increment here that this adjusts by. Or if you turn the feed off, you can advance it with the tenths button manually, 1/10 at a time. All right, now I wanted to test the grinding wheel out. There's no grinding wheel on it, it's all taken off. But let's start it and see how the bearings are. Now there's a bearing journal on this side, bearing cluster. There's another set over here. So they're both sitting here at 68, Southern California in the winter. And let's fire it up and then see where it's at after intermittent time periods. $99. $112. I think that's enough of running it.
We're at 17 minutes.
Yeah. So in 15 minutes, we went from 68 to 112. 44 degrees. Okay. So we've made it through the hydraulic system. That's a win. We've made it through the spindle. We know where to get the hub. That's a win. We got our DC motor and the original wiring works just fine. That's a win. There's a few other things to do the machine, but clearly at this point, it's not a boat anchor. This is going to be a very effective tool for our shop. Get uglies. Make sure your wiring's right. That's what some of the problems were with the machine. Not mechanical, they were electrical. If you need some help, find a qualified electrician. I think it's awesome.